Humans have always had an odd tendency. Some call it being self-centered, but as the only intelligent species that inhabit our planet, we like to be very self-centered. Being the selfish beings we are, we thought that we may be the only ones in this grand universe. The only ones to expand and find nothing. We have only seen life once, after all. Believing in only a flat earth with the whole universe revolving around us. Only until 1543 did we think we were not the center of the universe, when Copernicus published De Rebus Obras Celestias, which, in Italian, means on the revolutions of celestial spheres. Later, in 1898, a book called The War of the Worlds by H.G. Wells was released, where aliens from Mars invaded Earth, and this sparked fascination on space and extraterrestrial life. People began to think of the possibilities for other intelligence far beyond planets not seen by Earth. But this forced the fact that our foreign celestial neighbors may not be friendly. If they had such powerful technology, then they could just kill us all, was the impression most readers got from this book about war and space. This book led to the development of modern conceptions of the extraterrestrial. So humans, with their curiosity, entered the information age with a fresh sense of fear for the unknown in space. We started the hunt, ready to find our new friends and foes, and found nothing. Our spaceships unimpeded, our satellites hearing nothing. Our grand telescopes looking out into beautiful interstellar images, but no life. Maybe there's another alien civilization wondering the same thing and reaching out into the stars for an answer. Or are we just alone?
If our galaxy contains hundreds of trillions of stars, and each of those stars has a solar system, and in that system there must be plenty of planets. At least one of those planets must host the conditions for life, right? So why don't we see aliens and ships in our skies, and at the very least, why haven't we been contacted by them? This is where the Fermi paradox is set into motion. Enrico Fermi was an Italian physicist who produced this theory on a sunny afternoon after having a chat with his fellow scientists. While walking to lunch, the men discussed about aliens and faster than light travel until Enrico blurted out, "But where is everybody?" There have been many attempts to resolve this paradox, such as that aliens are extremely far away from us, or that we have not been around long enough to see advanced civilizations to develop. Each of these theories were as unsatisfying as the actual paradox. With these facts in mind, we can also think more practically. There are billions of stars in our galaxy, the Milky Way, most of them being much older than our Sun. Logically, many of these stars, hence their planets, must have Earth-like planets in a habitable zone, much like our own. If these planets are much older than Earth, there must be a chance that intelligent life has had time to develop. If Earth-like planets are typical, some must have formed a lot like we have. So, some of these civilizations must have developed interstellar travel, which we are still investigating in, but with this theory in mind, we can assume that maybe Earth was visited by extraterrestrial beings or their probes. However, there is no convincing evidence that this ever happened. The paradox is an argument with the overall scale and probability it seems to favor intelligent life in our universe, as well as the total lack of evidence of life ever happening other than us. So, as the paradox presents itself, we don't have a plausible explanation, and we can only keep on producing ideas that deepen our understanding of it all. This is where we can put an equation like the Fermi paradox and add more mathematical logic. By doing so, we can theoretically fill in the blanks of what we're missing, and in comes the Grabby aliens theory.
The Grabby aliens theory is the best explanation for our supposed specialness. The Copernicus principle is the fact that we are not and cannot be special. It's almost impossible for us to be in a scenario where we are extraordinary from the rest of the universe. So, we come to the Grabby aliens theory and its bases. The theory is made up of three base ideas: that spacefaring life will expand at a percentage of the speed of light, will make visible changes in any solar system they inhabit, and last a long time. These three ideas make up why we can't see aliens and why we seem alone in the universe. Expansion of said aliens can also be estimated by using this model. This is the only way we can explain the loneliness we find ourselves in. To explain these ideas of the Grabby aliens model, we will go furthermore into each idea. With this model, we can find out the question of humanity. Why are we so early?
The speed of light is something we are remarkably familiar with, yet it remains very unreachable, and we can only produce concepts to fathom it. The speed of light is a universal constant that is exactly equal to 299,792,458 meters per second. All forms of electromagnetic radiation, including visible light, travel at the speed of light. For many practical purposes, light can almost be instantaneous for transmitting signals or visual interpretation. However, for long distances and extremely sensitive measurements, its finite speed has noticeable effects. Any starlight viewed from Earth is from the distant past, allowing humans to study visuals of the universe by viewing distant objects. 100% of the speed of light can't be achieved by anything made from matter, so technically, we can't travel at light speed, however, we can achieve a percentage of it. With today's technology, we can't produce some mega powerful rocket engine that could accelerate us to it instantly, but we can get a similar effect by using something called a solar sail. A solar sail is a rectangular shell-shaped device which uses synthetic lasers or electromagnetic rays from the sun to accelerate itself to a percentile of the speed of light. So far, no test has been conducted using the solar sail, but researchers have theorized that we could reach 20% of the speed of light, which doesn't sound like much, but with that information in mind, we can reach the nearest star system, Proxima Centauri, in 21.25 years. Maybe then, we can theorize ways to contact other civilizations by means of a space probe. But if this is the case, then why not more older and more advanced alien civilizations contact us with the same way? Perhaps aliens just haven't discovered methods of travel like we have, or they're still on the way here.
Life cannot be a one-time ordeal. We must assume that we are not the only ones, and life can and will find other places to exist. But what are the chances for said life? And how do we know when it turns intelligent? We need to first look at where life can begin, on habitable planets. The requirements for a planet to be habitable are as follows: a good atmosphere that allows gases to be stable, liquid water, a temperate climate for life to start, a solid surface so many life forms can inhabit the planet, and a good chemical mix of carbon, oxygen, nitrogen, phosphorus, and hydrogen. We don't know what life needs to persist, so there could be many other chemicals that sustains life. However, we only have life forms on our planet to study. The planet needs to be in a constant solar system, allowing life time to develop. The star needs to have a very long lifetime and not scorch the planet's temperatures. With these conditions, habitable planets are formed, and life, in time, may inhabit them. But there are many more facts at play for life to develop. These are called hard steps and great filters. Hard steps in terms of life are hard evolutionary processes that takes hundreds of years for life to overcome. Humans have gone through many of these hard steps, and it took all that to get where we are today. Great filters, on the other hand, are steps every early intelligent species will go through, even things out of our control. Many great filters we have gone through, and scientists think there should maybe be some left. This is one reason we don't see millions of alien civilizations. These hard steps and filters force life to adapt or die trying. We would not be here in this amount of time if life even took longer to develop. Life takes so long to overcome hard steps, we think that it takes about 0.4 million years to overcome a hard step. Hard steps, by definition, are just simply hard evolutionary processes. So, with this, we can look into the greater picture. We think that every year has a small chance of overcoming a hard step. And as time goes on, every year, just a little bit, it becomes greater, by zeros of percentages. Hard steps may take so long that planets become uninhabitable before intelligence is formed. This is why we've only seen life once, on our own planet. And this is what humans and other civilizations must go through to become Grabby. But what puts the Grabby in Grabby aliens? This is where loud and quiet aliens comes into play. Loud aliens are Grabby. They expand in every direction at very fast speeds and last millions of years, making noticeable directions wherever they go. Quiet aliens do not fit one of those expectations. When new land was discovered, the ones who settled it reaped the benefits. This encourages Grabby characteristics in species. It only makes sense that we would expand rapidly and fast when we reach other star systems. This is why we can't see other aliens. They're too far from us and they're too fast, so we can't see them expand. Once we see them in one system, we'll find them in every other system because of how light works.
So now understanding the ideas more, what can we say about our place in the universe? Are we early? It's hard to say, but it seems we're among the first. Using this model, we can estimate when we started in a large time frame. On the left is the number of hard steps it takes to get from a dead matter civilization to a spacefaring one. Scientists think we've gone through 6 now. Then, at the bottom is how much time a planet will stay habitable using a time frame of billions of years. We now know that Earth only has a billion years left. So, by using the model, we can assume that we are the first 10 to 25% of all civilizations to exist. We can also see when Grabby civilizations are born and the expansion they will go through. Here are the models to understand the expansion of the aliens. Here is where Grabby civilizations were born and when they started to expand into space. As the model moves down, you can see as the rate they expand. Once a Grabby civilization meets another, they will stop, and we don't know what will happen beyond that point. As you see, after a long amount of time, all expansion stops, and the universe is full of Grabby civilizations. Look at the aliens that were first born. They got the most, and the ones that were born later got far less. This makes a time deadline for new Grabby civilizations, as all the inhabitable planets that could, once in a million years, have produced a new Grabby civilization, then another one can inhabit it. So, there is a deadline for new Grabby civilizations to be born because of the amount of space that will be taken up by others, so then we can assume that we are far away from any Grabby aliens. Or are we early? This is why the model solves our specialness. We may never know if our universe is inhabited by aliens. We can only come up with theories that quench our understanding of the unknown universe.
Maybe we are still in the dark about this. Perhaps the aliens haven't reached us yet, or they're just waiting for the perfect time to strike.
Our Earth may not be as important as we think of it in the grand scheme of things.
By using the Grabby aliens model, we can predict the steady evolution of alien civilizations and how they spread and divide around our universe.
So here's the question.
Are we truly alone?
Or are we just lucky?
We may never know.